different scenarios that can happen with L'Hopital rule. So one scenario is that you have to basically do L'Hopital rule multiple times to end up with a right answer. And so here, limit as x approaches 0 e to the power x minus x minus 1 over cosine of x minus 1. This is, if I plug in, I get the 0 over 0 form. And so let's try to do L'Hopital rule. So according to L'Hopital rule, this is going to be limit as x approaches 0, and then the entire numerator derivative, the entire denominator derivative. So the numerator derivative of numerator, don't forget the limit, otherwise it's not going to be the same thing. So e to the power x minus 1 over negative sine of x. Hold on. So e to the power x minus 1, if I plug in 0 is 0, denominator is 0 also, so I get another form, 0 over 0. And what do? I do another L'Hopital rule. And limit x goes to 0. This time I'm taking derivative of this, whatever is in the numerator and denominator. Don't forget the limit, and then you get e to the power x over negative cosine of x. If you plug in 0, you end up with negative 1. So the example that we just did, and it was twice 0 over 0. Now let's do infinity over infinity. This one I know the answer is limit of negative 3x to x cubed minus 20x squared over 2x cubed plus x plus 7. As x goes to infinity, these two are the highest power, and then the highest power are the same. Therefore, what I get is the ratio of the coefficient, negative 3 over 2. Let's see if this is working still with L'Hopital rule. And the form is, as it says, infinity over infinity. So do a L'Hopital rule, and we get limit, the derivative of top. I'm not writing derivative, I'm just doing the derivative, and minus 40x, and derivative of bottom is 6x squared plus 1, x approaches infinity. Okay, this is again infinity over infinity, so I do another L'Hopital rule. This time I'm taking the derivative of the new one, and so here derivative of that one is negative 18x minus 40. Derivative of this one is 12x, and then again infinity over infinity. Then this time I'm writing it here. I do another LHR, and limit as x goes to infinity, negative 18 over 12, which negative 18 over 12 I can simplify by 6, and then it's going to be negative 3 over 2, which you were expecting. So it works with LHR, and it works as it works naturally with other methods that we have. So as we're doing the examples, I kept repeating a few things. First of all, the L'Hopital rule only works when the indeterminate form is 0 over 0 and infinity over infinity. Otherwise, it doesn't work. The second thing is that don't confuse the L'Hopital rule with the quotient rule. L'Hopital rule and quotient rule are different things. L'Hopital rule is to find the limit. Quotient rule is to evaluate derivatives. So one is for evaluating limits and the other one for evaluating the derivative. Now, interestingly enough, we can use L'Hopital rule for a few other basically limits other than infinity over infinity or 0 over 0. But what we need to do is we need to convert them somehow to make it 0 over 0 or infinity over infinity. And that's the next section that we discuss.